I'd like to talk to you about three things today. First of all, I'd like to slip in a little talk about CR and cancer and just tell you a little about HCC and the effects of CR on that. And then calorie restriction. And then talk to you about screening for longevity therapeutics or geroprotectants. Using lifespan assays, I'll talk to you about Drosophila and then about mice. Okay, so HCC is a very common cancer. It's the fifth most common in humans. It's the third leading cause of death from cancer. There's about 500,000 people die per year from hepatocellular carcinoma. Untreated patients die in 3 to 4 months. If you're treated and you respond, which not everyone does, then you'll live 6 to 18 months. So clearly we need better therapeutics than we have for hepatocellular carcinoma. This project got its start a few years ago when we noticed that taking mice who had eaten almost all they wanted for almost all of their life, for half their life, were shifted to a calorically restricted diet, that they shifted very quickly. We started those diets at 19 months. They shifted very quickly to a new mortality trajectory. And that mortality trajectory was associated with lower incidence of death from cancer, about 3-fold lower. And this strain of mouse just happens to die of hepatocellular carcinoma about 90% of the time. So it was a good model for studying that. And when we took mice that were old and just killed them all and took the tumors from the ones who had tumors, we found that the tumors were smaller, no matter how you sliced or diced the data, with time on CR. And this is 2 weeks on calorie restriction, 4 weeks, 8 weeks, or 16 weeks, that the tumors we harvested were smaller the longer they'd been on CR. And we're starting a project actually to look at this longitudinally using CT scans, so that we can actually see if the tumors shrink or they grow more slowly. Now, this is signaling through the growth factor receptors. Here's the insulin receptor. It phosphorylates itself and signals down this branch of the signaling pathway to S6 kinase, which is a kind of a readout for this pathway. And it's very nice because you can look just for the phosphorylations of some intermediates in this pathway, and that tells you about the activation of the pathway. How active is it? Now, insulin receptor signals mostly down this branch, which goes to glucose utilization and protein metabolism. IGF-1 receptor that we've heard about this morning from Holly Brownberg signals partially down this side of the pathway, but mostly down the growth factor side of the pathway and down to the MAPK kinases, and then on to cell growth, cell division, and resistance to apoptosis. Another receptor that I've thrown in here, because I'll talk about it, that is the EGF receptor. That's epidermal growth factor receptor, and it has quite a family of ligands that I'll just briefly mention. So when we looked at activation of this pathway after time on CR, so we've taken old animals, shifted them to calorie restriction, harvested their tumors, and then we're asking from a number of tumors from different animals about the activation, that is the phosphorylation, the level of the protein for the insulin receptor, and the phosphorylation of that protein. You can see that with time on CR, 2 weeks, 4 weeks, 8 weeks, and 16 weeks, the phosphorylation and the amount of the insulin receptor really doesn't change. Not surprisingly, though, we find that the IGF-1 receptor is downregulated in amount and in its phosphorylation state, that is its activity, with time on calorie restriction. And so the longer you're on calorie restriction, or if you're a mouse, the less signaling is coming down through the signaling branch of the pathway. So here we see no change in the phosphorylation state or amount of the insulin receptor. However, the IGF-1 receptor is going down. And so, of course, then it's interesting to know about the readouts for these two pathways. And just to make a long story short, if you look at S6 kinase, which is the readout for the glucose utilization part of the pathway, it doesn't change. So this is going down, this is not changing, and this side is not changing. So signaling down this way in the tumors is staying pretty much the same even in CR. In contrast, if you look at the MAP kinases, that is ERK1 and 2, and look at your phosphorylation state, you see that with time on CR, the phosphorylation state's decreasing. In fact, it's decreasing. This is tumor tissue. This is control tissue, either harvested adjacent to the tumor in normal tissue or from a mouse that didn't have a tumor in the liver, and it's the same either way. And what you can see is that there is less phosphorylation of the MAP kinases. And then, interestingly, the EGF receptor, this is phosphorylation of the EGF receptor, also goes down with time on CR and is not statistically different than the phosphorylation in the control tissue. This is the first evidence I know of that EGF receptor is responding to CR. And I think this is important because, okay, so we have the EGF receptor is down in phosphorylation, the IGF-1 receptor is down. The ERKs are down as well, the MAP kinases. So we're getting the same signaling down this side, but through this cell growth, division, and anti-apoptotic pathway, there's a decrease in the tumors with time on CR. That's why we think the tumors are either shrinking or not growing as quickly. We've not put a lot of effort in trying to find out which of those it is, and we don't really know yet. So that's, I think, very, oh, let me go back just a second and say this is especially significant. There are a lot of ligands for the EGF receptor. Tumors have been reported, these are mammary tumors, prostate tumors, not HCC, but other tumors have been reported to auto-stimulate their own growth. So they're an autocrine stimulation by producing these ligands and secreting these ligands for the EGF receptor. So of course we're very interested in the level of those ligands and their activation. And for activating this EGF receptor, there are other growth factor receptors as well that we think may be responding to CR2. And that's, we all know about IGF-1 receptor. There's really nothing in the literature at all about other growth factor receptors and the autocrine stimulation of their growth in cancer. So now I'd like to talk to you about screening longevity therapeutics, and first just very quickly about doing it in flies. So we have a Drosophila project. We've spent a lot of time figuring out how to lower the volume of the medium so that we can screen drug libraries that you buy. They come in 96 well plates and you don't get much. And so we've finally done that so the media doesn't dry out, etc. We use male flies only so we don't have the egg-laying problem that you get. We use 200 test flies and 400 controls using imbalanced design. Miller has championed. And we screen, and I'm just going to talk to you about our screen of this protein kinase inhibitor library. And I'll just tell you, we screened 80 compounds at high and low concentrations, and that's just defined by how much came in the library. So we used 90% of it in the high and 10% of it in the low. We got 23 initial positives out of that. 10 of those so far have verified. That is, they went on in further dose response studies to also extend Drosophila lifespan. We have 13 of these that are in progress now to define a dose response. And I'll just show you. Here is a screening. So here's the control here. Some of the kinase inhibitors kill the flies. We found a lot of expensive killers of flies. This is a case where a low and then a higher dose of this inhibitor, and this inhibits the